welcome to CBE 6. We'll be discussing linear equations and their graphs. You know what we're going to be talking about, right? Yeah, we'll be fine. Okay. Now I can't get you to freaking move on. There he goes. Now you want to move on. Okay. Linear equations create a line between, or a line which represents visually represents. That doesn't make any sense. All x and y combinations that make this equation true. We can look at specific x values and find what the corresponding y value would be that would make it true. That makes sense, yeah. Right? You can go to any point on the x-axis, go up, and that's going to be your y value.
Yeah.
Okay, so drawing the graph of the linear equation, x plus 5y is equal to negative 10. Where would we start?
So is this the one where you put your hand over one and then divide it by, or do stuff like that?
You can.
Okay.
Yeah, so one is you set like x to 0 and figure out what y would be when x is 0, and then set y to 0, figure out what x would be.
Okay, yeah, that makes sense. Yep.
Yeah, exactly. So with this guy, we're given this funky equation. Do we want it like that?
No.
Now, how do we want it to look?
You're going to want it to be x equals 5y minus 10, or negative 5y minus 10. You isolate the x and then isolate the y. Is that what I'm understanding?
We could do that. We could isolate the x. But remember, our basic form that we learned about in this class was y equals mx plus b, right?
Yeah. Okay.
Yeah, our sloped-intercept form. So we want the y alone. You can do it with the x and then graph it kind of like the inverse way. But that's confusing, and I don't want to do that. So
I keep confusing it with f of x.
Oh, yeah.
Oh, yeah. But yeah, you had the right idea then. Yeah, exactly. So then we're going to isolate the y. So we're going to move the x over, and we get negative x minus 10. And then we divide through by 5. So we're going to end up with negative 1/5. I hate this so much. X minus 2, right?
Mm-hmm. Yeah.
Okay, perfect. So now what?
You graph the minus 2.
Yep.
And then it's negative. It's negative. Is that negative 1/5? I can't
Yes.
really see.
Sorry. Y equals negative 1/5 x minus 2.
Yeah. So you graph the negative 2, and then you graph the equation. So 0, negative 2, and then go down 1 and over 5.
Yes.
Yep. Exactly. Yeah. So our negative 2 is going to go on our y-axis here, right? Because that's our intercept. And then, yeah, you're right. We go down 1, because it's rise over run, and then over 5. 1, 2, 3, 4, 5. We get right here. Let's see if this has the fancy hold trick. It doesn't. I'm really bad at drawing lines. It's going to look something like that, but less wavy, because I'm just really bad at drawing lines. Make sense?
Yeah.
Any questions? Good stuff. Actually, real quick question. Does it matter if we go down 1 or left? Does it matter which way we applied the negative? If we had because we have negative 1/5, right? Can we apply the negative to the 1 or to the 5?
No, I don't believe so. I can't remember.
That's okay. Yes, we can, right?
So
if it's a negative 1, it means we go down 1 and then over 5 to the right.
So
if we apply it to the
negative 5.
If we apply it to the negative 5, we go up 1 and then left 5. But either way, we're going to get the same line.
Okay.
Just so you know.
Yeah. So with the problem on the CBE, it's just you need to end up finding 2 points ultimately, and then graph it like this. Okay. So we got slope of a line. Slope of a line is a comparison of the change in the y to the change in the x. This ratio will be constant between any 2 points on the line. So it's our rise over our run, right? How much we go up or down divided by how much we go left or right. The equation for slope is y2 minus y1 over x2 minus x1.
Okay.
That is how, like, if we're given 2 points, how we would find the slope between the 2 points. And then just as remember to stay consistent with which point is 1 and 2. So it doesn't matter which one you put first. It just, if you use the y from 1 equation as your y2, then your x2 has to be the x from the same point. So you got a problem like this where we're given 2 points and it says find the slope of the line that contains these 2 points.
I logged it as average.
Okay, so yeah, if you want to go ahead and do a little bit of it.
I
Numeric equation. So what's our first step we want to do? Get these points.
So you want to put it in the y2 over minus y2 minus y1 over x2 minus x1.
Yep, exactly. And so it doesn't matter which one we use as our 2. I like to use the second point as our 2. It makes sense to me, but you could do it the other way around. I said as long as you're consistent. So we get that minus, and then just make sure that you got minus a negative. So you just need to have it as that over 2 minus 1/2. Okay. And I just want to go ahead and solve this. So we got our fractions within a fraction. So first we just want to simplify down the numerator and the denominator. So we got 5/4 plus, I guess if we got a numerator, we got negative 5/4 plus 4. And then we could go ahead and find the common denominator with our adding. So we're going to get 11 over 4. Right. And then our denominator will be 2 minus 1/2, which same sort of thing, find a common denominator and divide. So this equal to 11/4 over 3/2. Okay, any questions about how we got there?
Okay. Yeah, so just leave it in the improper fraction?
Yeah, for now. Okay. And then we need to simplify this. But yeah, first just improper fraction, do the, subtract the two things. Mm-hmm. Okay, and then now we have a fraction divided by a fraction, and we don't want to keep it in that form. So how do we divide fractions?
You times it?
Yes. Yeah, so we take the first one, and then we multiply it by the reciprocal of the second one. So first divided by the second, or you flip the second. And you can go ahead and
he gives you all the equations.
Multiply across. And now just on the CBE, it will accept this as an answer.
Okay.
You don't have simplified past it, you can. So like 22 and 12 both have 2. So you can pull the 2 out.
So accept 22 over 12 and 11 over 6.
Yep, and it will accept 11 over 6. So it won't accept this answer, like that. It won't accept that, but
okay.
Yeah, the other ones it will accept. So, and then here, I think, it simplified down to 11 over 6.
What's the next step? Okay, so determine the equation of the line that contains these points. So, you already found the slope of the line, right?
And know how to find the slope of the line.
Right, you know how to find the slope of the line.
Yeah.
So we're going to do the same thing here, and then we're going to input it in that sloped intercept, or point slope form. Okay. Do you remember what that is?
It's the y minus y1 equals m x minus x1?
Exactly. Yes. Yep. Perfect. Y minus y1 equals m x minus x1. Okay. Do you want to work through this on your own? And then I'll work through it on my own, and then we'll compare?
Yeah.
Okay, let's do that. For my slope, I get 3 over...
Just does accept this as an answer. The CBE.
Oh, right. Okay. Did you get an answer?
I lost it because I'm somehow at y minus 6 equals 3/5 x minus 45 over 5. I'm trying to figure out where I screwed up.
So you have y minus 6, right?
Oh, yeah, that's what I forgot to do. I forgot to add the 6. Yep, that'll do.
Okay. So just so you know, the CBE will accept this answer. So once you find your slope of 3/5, you can just plug in y minus 6, right? Because I'm using this point here. So I'm taking y minus 6 and then 3/5 x minus 3. You can just plug this whole thing in.
No, I can just plug that in and
Yeah.
it'll accept it.
And it'll accept it. Then you
Okay.
don't have to worry about screwing up on algebra. I simplified it just in case you wanted to. This is what you should get. So you're saying I'm going to have, so 3/5 times negative 3. So we just multiply, this is the same as 3 over 1, right?
Yeah.
So we're going to multiply 3 over 1 by 3 over 5, and we get negative 9/5. And then we add the 6 over. We have to make it a common denominator, so we're going to multiply the top and bottom by 5. So we don't change the value. You get 30 over 5, and then you subtract the 9.
Yeah.
Perfect.
Yeah, that makes sense.
Make sense?
Yeah.
Good stuff. You're a smart man.
Cool. And there's a solution. As I said, that's in slope-intercept form, but it will just accept the y minus 6 equals 3/5 x minus 3. Okay. So we just got another one. In a way. So it's determine the equation of a line that contains this. Go ahead and solve for slope. Or have you been able to find your slope yet?
Yeah, I got that.
8 divided by 0. Now the problem is we can't divide any number by 0. That's undefined, right? And so we can't make your equation of a line that with the point slope form if our slope doesn't exist. So there's actually one type of line we have that does have a slope that's undefined. And so we had a coordinate axis. The slope is a line that's just straight up and down.
Okay, so if it's 8 over 0, it's straight up and down?
Yes.
Okay.
Yeah, so anything divided by 0, that's going to give us an undefined slope. In this case, is that. And the equation for a line that's straight up and down is x equals something. And so what our x can equal, we can look at our 2 points. And what do you notice about the x values in both points?
X values in both points, negative 6.
Yep, they're both negative 6, right? And so the equation for our line is just going to be x equals negative 6. So, pulling before you can kind of just look and see, okay, the x values are the same. If you solve for your slope, you're going to get an undefined number. And then you'll be like, oh, well, that means it's going to be x equals something. If the y values are the same, then you're going to get y equals something. And in that case, you're actually going to get a slope of 0. So you can put that in your point slope form if you want it with a slope of 0. Or you can just realize, oh, y values are the same, is y equals something.
Okay.
But in this case, yeah, slope is undefined. We can't make a line out of that. So it's going to be x equals whatever the x number is. Cool. Any questions about that? Perfect. And so, yep, we got our solution of x equals negative 6.
Perfect. Okay. Determine the equation of the line that contains the point 0, 3 and is parallel to this equation. How do we decide if something's parallel?
It would have the same slope.
Perfect. Quick quiz. How do we tell if something's perpendicular?
It's flipped. The slope is flipped. So like 1/3, it'd be 3 over 1, or negative 3 over 1.
Negative. Yep, it's the negative inverse. Perfect. You got it down. Okay, I just wanted to check because they might throw that at you on the CBE. Okay. Oh, it's the next question. Spoiler alert! It's the next question apparently. Okay, so for this one we want to start the same way, right? Isolating y, get it equal to something, and then we know it's gonna have the same slope, and then we can just put it in point slope form with this point to decide the equation. You want to do that? Yeah.
I'm working through it right now.
Yeah,
I think
perfect.
I got it. Yeah.
Give it a run through. I'll do it as well, and we can compare answers. Y.
Oh, well, over there. The prereqs for statics are just
Long. And physics one.
so it's gonna be easy if I speak Calc 3.
Yes, because they'll teach you a much more important way to do it in statics, and you'll just say, that's a double integral, I can do that. And then you'll do it a much easier way, by using double integral.
I don't know how to do it the other way.
So stupid.
It's because I'm gonna be done with math next semester. I'm taking ODEs.
Yeah.
So that means that I'll be like set for all of the
Yes.
like low level engineering classes.
Do you get an answer?
I got it when I did I got it, and then well I didn't I screwed up here. I'm just trying to figure out why I screwed up. Oh, that's why, because I didn't use that formula.
You didn't use the point slope form?
Yeah, I tried to do the y2 minus y1. That's what. Oh, no. I don't know what I did. I'm confused. But
That's okay. Here, I'll come.
yeah, I'm confused myself.
That's fine.
I don't remember.
Okay, so yeah, we isolated the y.
Yeah.
Divided everything by negative 2.
Two, where you just find the
And
slope.
you get.
If that part,
Why am
I guess I just-
what
did I do
wrong
wrong here?
So, your 3 should be positive here.
Okay.
But that shouldn't affect your answer too much because we don't care about that. We want to find the slope, and your slope is 9/2, which is correct. And then what we do is we take this slope and we put it into the point slope form, right? Which is y minus y1 equals m times.
X minus. Well, X.
Oh.
Yeah.
Yeah, perfect. So then we're going to take this slope and put that in for m, and then we have the point 0 at 3, and we're going to put that into that form. So what would that look like?
Yeah,
So
so this one you don't have to, but like if they gave you the point like 3, 2,
Yeah.
then this is a lot easier, because it's just y minus 2,
it is
x minus 3.
X1 is 0.
You don't have to like
And then
do more math. And the CBE accepts
X plus 3.
form. It actually accepts literally anything as long as it's that's the right answer. So you could just say
That's perfect? Okay,
that's
what I got.
Yeah. So I just confused myself. All right.
Yeah, that's okay. Happens. If you confuse yourself, you kind of get lost in the problem. You don't know what you're going to do.
Just add a
You know
bunch
what
of
you're supposed to be doing.
CBE.
What I would do is I'd scratch all your work and then just pull out a new sheet of paper and work again.
Okay.
Start again. So, anyways, but yeah, you got it. Good stuff.
Multiply it out.
Look at this perpendicular. It was the next
Yes,
question.
It is. So on the CBE, you will get either a question with a parallel or one with perpendicular. We don't know which one. It's a test bank. You could get either one. But as we talked about before, what does it mean to have a slope that is perpendicular?
So it's going to be flipped. So yeah.
Yep, so we're gonna flip it, take the reciprocal, and then change the sign. So if it's negative, make it positive. If it's positive, make it negative. Perfect. So we got this line, we want to make it perpendicular. So how would you find the slope of this line?
So you're gonna find
To y
let's see.
such that x
You're going to isolate the y again.
Yep, exactly. We've been doing isolate the y.
I knew that.
rigorous definition.
That by 2.
The correct definition.
Okay, so we got our equation of that line. So the slope of this line is -2. So if we want to find a line that has a perpendicular to it, what's our slope gonna be for our new line?
Positive 1/2.
Positive 1/2, right? Change the sign and find the reciprocal. Okay, and then we're given a point. So now we want to make the equation of our line. Best way I know how to do it is point slope form. Find it not too hard. Take our y minus the y value of our point equals our slope times by x minus our x value of our point. Should get something in that form. So y minus 5 equals 1/2 times by, you can put x plus 4 or x minus -4. If you want, you can go ahead and solve it out. You get 1/2 x plus 5. Oh, sorry, not plus 5. Anyway, it's plus 7,
But how do you move?
but
First number?
you can also just leave it in point slope form.
Mm-hmm.
Yep. Any questions about how we give that line?
No, I understand.
Yes. Yeah. So also once you understand these, like there's like 4 equations of lines to find the slope and stuff, then it's just coming down to okay, what's actually our slope, what's it asking for, sort of thing. Anyway, we got next section. Go ahead and go. It's Sam going for transformations.
Transformations?
Is that
Oh,
correct?
I was- My mind went to Calc 3. I was
Oh.
like, what? We're not doing transformations. Okay, common functions. Linear, parabolic, the root function, and the absolute value. Do you remember what these guys look like?
Linear is a line.
It's a line.
Parabola is the U.
The U, yep.
I did the square root and absolute value last night. Why can't I remember it?
It's okay.
The one kind of goes up and like one goes up and then the other goes down. Like I can't describe.
That's okay.
Yeah.
Yep, so remember that we know that our squared and our square root are similar, right?
Yeah.
So we can say, oh, well, this one's just going to be this parabolic turned on its side, but it can't be negative, right? Because we can't have a negative answer outside of a square root.
Mhm.
So we know it's just going to be half of it. So it's going to look something like that, right? Where it's kind of like curved off into infinity. And then the absolute value is a v. Absolute value is v.
Okay.
Okay, so shifting. The horizontal shift is inside the function, and it shifts the graph horizontally, opposite to the sign. So if I have a positive in there, it's going to shift it left. If I have a negative in there, it's going to shift it right.
Yeah.
Make sense? Vertical shift, just like
Your
normal.
y-intercept on a
Yeah.
line.
It goes up and down. It does not dictate the y-intercept though. So if I have 5 in one of these equations, it doesn't mean my y-intercept is 5. It means I translate up 5. And then I translate left or right given my x. And then if it's negative, it's going to be flipped upside down or reflected across the x-axis. So, problem 7. The graph of the equation, this guy is the same shape as the graph, this guy. So what shape was that?
That shape is the sideways.
Yep,
half
it's going to look kind of like that. Yeah, exactly. It's going to look vaguely like that. Perfect. So, with these numbers here, we have a positive 72 and a positive 55. How do we transform that? How's that going to look?
So it's going to be negative on the 72 to the negative.
Yep.
And then 155 to the is it up 155 or down 155? That's kind of confusing me again.
That's okay. Which one do you, what's your gut telling you?
My guts tell me up.
Perfect. Yep, it's up. Right, so this one treats like normal. So if inside's opposite, then outside is normal.
Okay.
So if it's positive, it goes up. So then we're going to go up 155. Look at that. We shift left 72 and up 155. Okay.
Perfect. Okay. So problem 8, you're going to be able to see a couple different transformations, and it'll either be like a square root, or sorry, not a square root. It will be either squared or it'll be an absolute value. So we want to find the equation for this line. So first thing we want to decide is what kind of equation it is. Is it an absolute value? Is it a squared equation? What do you think this one's going to be?
Linear.
Not quite linear. Because linear would just be a single
It's an
line.
absolute value.
Yep.
It's a V.
Yep, absolute value because it's a V. So our graph, we know at first is going to be something with an absolute value in it. Okay? And then now when we translate it, the translation point on absolute value is going to be where the V meets. So that's the point we're going to be looking at. And so what's our translation going to be, left or right?
So this is where I get lost.
Okay. So first we can look at this point And we see the point is 2, 7, right? So it's 2 to the right and a 7 up.
Yeah,
Okay, so if we want to make something 2 to the right, how are we going to write that?
plus 2.
It's actually going to be...
Oh, wait, no, it's minus 2 because it's
Yep,
absolute
because
value.
it's in that. So yes. So with the x, it's always going to be opposite.
Yeah.
So we're going to put an absolute value, and it's going to be 2 to the right. And now if we want to go 7 up,
If we want to go 7 up, we're going to do plus 7 on the outside.
exactly, plus 7 on the outside. Okay, so now we've translated it. And now the last thing we want to check for is whether we need a negative or not. Okay, this is a v and it's going downwards, right? So is that going to be a negative absolute value or a positive absolute value?
That's going to be a negative.
Going to be a negative absolute value, right? So you can go negative absolute value, right? And we moved it 2 to the right and 7 up.
Okay.
And so that'll be our answer. And so we could do a similar sort of thing. If this graph were to be a parabola, so it'd be something like that, what would we change in this graph?
So if it was a parabola, would that be the x minus 2 in parentheses squared?
Yes. Yep. So if it's a parabola, we keep, right, it's still upside down, so it's still a negative. It's still 2 to the right, but instead of absolute values, now we're going to square it, and it's still 2 up. Sorry, 2 to the right's a negative. Yep. So, yeah, first figure out what type of graph it is, then you could do it in really any order. You could first do the negatives, or you can first translate it.
Mm-hmm.
But, yep, if it goes to the right, it's negative within the x. If it's up or down, it's
So with the x,
same.
it's reverse, and then with the outside, it's always
Yep.
at the same time. Okay.
It's always the same. Yep. Little confusing, little backwards it seems like, but that's how math works sometimes. Perfect. So you got our equation, yep, y equals negative absolute value x minus 2 plus 7.
Perfect. Systems of equations. These are fun. Okay. So if you're looking for a solution that makes all of the equations true, right? Because you need both of them to be true at the same time. So essentially we're graphing two lines. We're looking for where they meet. Different methods for solving the systems of equations include graphing. Oh, look at that. Find out where they cross. Substitution, and then elimination, which is eliminating a variable using both equations. Now we're going to talk about substitution now, for now.
Okay.
Okay, so problem 9, solve the system of equations. So, when we're given these two equations, right, what we want to do is we want to solve the system for one variable. Doesn't matter x or y. Or we want to solve any equation for one variable. Doesn't matter x or y. This one, it's nice. It gives us y already. Y is already by itself, so we know y is equivalent to negative 3/5 x plus 1. So now we can look at this equation down here, and we can say, well, we know what y is equal to. Y is equal to this. So now I can just put this whole expression in for y and then solve, because then I only have one variable, right? So this becomes 2x plus 3, and then put the parenthetical, right? We need to put that, because otherwise we're going to change the value of this expression. So we're going to say negative 3/5 x plus 1 equals 2, right?
Mm-hmm.
And then we would solve for x. Sound good?
Yeah.
Awesome. Let's work through this, shall we? We're going to distribute this through. We're going to get 2x plus 3 times negative 3/5 is...
So, let's see.
I'm putting you on the spot, don't worry.
So negative 9, no. Is it
Yep.
negative 9 over 15?
Negative 9 over 5.
Oh, yeah.
Right, yep, because
Yeah.
this is equivalent to 3 over 1.
Yeah, that's what. Okay, that
Yeah.
makes sense.
And then plus 3 equals 2. Perfect. Now we can solve here. We need to make sure we have a common denominator. So this is going to become, this 2x is going to become 10/5 x plus negative 9/5 plus 3 equals 2. Now we can...
X on the negative 9/5.
Huh?
There's an x on the negative 9/5.
Yep, there is. There's a negative x there. This is why Matt's here, to make sure I actually do things right. 1/5 x equals negative 1, right? So then I subtract the 3 over. You're doing it, I'm sure already. And then x equals negative 5. Is that what you got?
Yeah.
Perfect. Look at that. Solving a system equation. You got it down.
Solve for y.
Oh, solve for y.
And now we plug it in.
If you want, you can solve for y.
It's
You don't
kind of like
have
required to pass it.
to. Okay. Solve for y then. Yeah. We're going to take this. We're going to plug it in. I want to do the top equation. It looks a lot easier. So I'm going to plug it into the top equation. Negative 5 times negative 3/5. You know what that is off the top of your head?
Negative 5 times negative 3/5.
Yep.
I don't know off the top of my head.
That's okay. So we're going to get y is equal to negative 3/5. Negative 5 is the same as negative 5 over 1, right?
No. Okay, so that would be 15 over 5, which would be 30.
Yep. Equals, I should probably, there's a plus 1 in there.
That's
Sorry. I can't erase right now. And then y is equal to 4. Right?
Yeah.
Okay. Required to pass. Do all your work.
Yes, and it's gonna want it in a point format. So your x and then your y. Cool.
Okay.
Yep, solution negative 5 and 4 in parentheses. Okay, so we got another one. There's a few different ways you can solve systems of equations. The substitution method will always work, so you can do that. There's another way named with elimination that, depending on how the problem is set up, can be easier. How the CBE set up problem 9 is usually easiest to do substitution for, and problem 10 is usually easiest to do elimination. How elimination works is that you want to get your two equations and then you're going to add them together. And you want one of your variables to go away. This one, they made really nice for us. And if we add them, we get 5x plus negative 4x is just x.
Yeah.
Y plus a negative y is 0. And then 0 plus 4 is 4. So we add them, we get x equals 4. Then we can go ahead and plug that into either one of our equations. I'm going to choose the top one because there's a 0 in it, and I like zeros. So we take 5 times by 4 plus y equals 0. Right? And then we solve for y. So we can get 20 plus y equals 0, or y equals negative 20. And then we can go ahead and write that as a solution of 4, negative 20. Cool. Now, this one doesn't do it, but you could get on the CBE, so we'll go ahead and throw a little weirder one at you. If we were to have 5x plus 2y equals 0, and 4x minus y equals 4, keep it pretty much the same, but now if we add them together, our y doesn't go away, right? Because we just get a y. So how can we change this to make it so our y can go away when we add it together?
Or, let's see. So it's x plus y equals 4. Could you just subtract from?
It's infinitely easier.
Yeah, so what we want to do is eventually we want to be able to add them together,
Yeah.
right, and get an equation that doesn't have a y, or doesn't have an x. But in this case, y is going to be easier. What we can do is we could take one of our equations and multiply it by a number, by everything by that number, by just a number,
Okay.
right? And so if we multiply our bottom by 2, right, we're going to have our top equation will stay the same,
And then depending on the
but our bottom equation would be negative 8x minus 2y equals 8, right? So if you take an equation, multiply it all by one number, so it could be a positive number, negative number. Okay, now what happens if we add this together?
Okay. Oh, I see what you did. Yeah.
Yep. So we want to, so the first one was really nice. We didn't have to multiply anything by anything because it already had a positive y and a negative y. But in this new one, we have a 2y and just a negative 1y. So we want multiply 1 by 2, or the second one by 2. And now we can add it. We're going to get negative 3x equals 8. So x would equal negative 8 thirds. and then we can plug that back into one of our equations. Same sort of thing. I don't know what that's gonna be, but
Okay.
yeah. But so you could do that, and like I said, you can also, if you find it easier, you could do substitution. You're just gonna have to solve for either y or x first. So these ones are usually made pretty nice to do elimination like this. Cool. So any questions about systems of equations?
Are there two?
There's two for this.
Could we do another one of those?
Yeah. So let's see. We'll go ahead and do. I think that's our solution. Other research. We'll do it on our other research. This is the last question. Okay. So we're gonna go ahead and pull out another one. You want one doing like elimination sort of thing?
Yeah, do the weird elimination.
Yes. Okay.
Yeah.
Perfect. Okay. We're gonna do 2x minus y equals 4. Hopefully these numbers turn out nicely. I don't know. I'm just coming up with these right now. Okay. And then we're going to do 4x plus 3y equals 7. And actually, I'm going to change this a little bit. Ooh. Okay. Sorry. We're going to do. Oh, come on. Okay, 2x, and then we're going to do plus 3y equals 4. Okay, so we get 2x plus 3y equals 4, and a 4x plus 5y equals 7. Okay. How are we going to want to modify this? To get rid of either x or y?
Multiply the top by 2, so that
Right.
we get 4x.
Yep, if we multiply the top by 2, we're going to get 4x plus 6y equals 8. Except for the one thing is, if we look at this, if we add those together, we're going to get 8x.
We're still in the same boat, yeah.
We're still in the same boat. So what's another number we can multiply it by to get something a negative?
No, so -2.
Yep, so we did -2. You can also just, if you did 2 and you look and you're like, wait, that doesn't, work. Just, change everything to a negative. Cool. So we got this. Okay, and we want to go ahead and add those together. Now our x's, super nice, they go away. And we're left with a negative y equals -1. Right, so our y is equal to 1. It's working out pretty nicely.
4, 3, 7.
Yep. Oh, wait. Bottom one's 4, 5, 7.
Let him believe that it's correct.
Cool. And then now we found our y, how do we go ahead and find our x?
You substitute it in.
Yep, substitute it in. If we look at our first equation, I feel like that's going to be a decently nice one to put into. So we're going to get a 2x plus 3 times by 1 equals 4. So we get 2x plus 3 equals 4. Go ahead and subtract our 3 over. So we get 4 minus 3 is 1. And divide by 2, we get x is 1/2. Is that what you got?
Yeah, that's what I got.
Perfect.
What I got.
Nice. Cool. Well, is there any more questions? We could do more examples. We could be done. Like I said, this is the end of the slides here.
Let's what's it called? Let's see. Which one do I want to do? Could we do more equation of a line? I'm trying to just.
Perfect.
Yeah.
Do you want to do one where we have like 2 points and find the equation of the line between those 2 points, or one where we had like equation of a line that's like perpendicular,
Yeah,
parallel?
perpendicular and parallel.
Okay, perfect. Hey Sam, go ahead and make a problem for equation of a line that's perpendicular to another line.
Perpendicular to another line? Do you want... Okay, we'll do that. Let's see here. Let's say we're going to do 6x plus 3y equals 9. And then we want something... perpendicular perpendicular. That's what this little upside down T means. Right? And then, what point should we do? We'll make it easy. 3, 4. Or 0, 4.
0, 4.
0, 4. I don't know. I thought 0.
I can orthonormalize them for you.
I could orthonormal. Yeah. Okay. Y is equal to You're so right. Go back. No! Stop it! I can't get this thing to work. It's the worst. Oh gosh. Alright, you just got rid of everything. That's fine.
I do have it. Yeah, but I don't take notes on it.
Oh.
I take paper notes. Because I don't want to pay for like a software to take notes.
Oh my gosh.
Yeah, pay for software.
Samsung Notes is free.
Yeah, Samsung is free. But it doesn't use OneNote. Yeah. We're using the software.
The,
I don't know what I'm doing. Stop it. Serenity now. I hate this thing. Y minus 4 is equal to 1/2 x minus 0. Y equals 1/2 x plus 4. Is that what you got?
Yes.
Perfect. Took me forever because this iPad freaking sucks. Okay. Make sense?
Yeah.
Do we feel confident?
I do, yeah.
Utterly confident.
Surprisingly, yes.
Indubitably.
You're a genius. Dude, you're gonna nail this.
Awesome.
Do you have any other questions for us?
No.
Okay.
You already passed CB5?
Good
Yeah.
luck.